Hello, the problem of the day of this LeetCode. So let's see what is the question. You can basically read in LeetCode. I will just explain you what is question saying. Okay, so you have given an array. Okay, and we have to take out the smallest two integer that is present in array. Okay, and what you have to do is that we have to remove those numbers and simply add this. What is this? Minimum of x and y into mid2 plus maximum of x and y anywhere in the array. Okay, so that only we have to apply this till the whole, basically the numbers in the array becomes greater than or equals to integer k that we will be given. Okay, so we have to apply these operation. Okay, and we have to apply at least the elements should be 2 of us. We have to see that if elements are less than 2 or basically 1, simply we don't have to apply and return and simply it will not be given. Okay, so let's see the question. Okay, so this is the I'm explaining the question. Basically there are elements here and we have given an k. Okay, so what will the minimum element for first thing? Okay, for this example, for first iteration, minimum element will be 1 and 2. Okay, so what we have to do next? We have to remove them. So we will simply remove them. The remaining will be 11, 10 and 3. Okay, so the first key is that if all the elements are given equal or greater than k, then simply we don't have to apply operation. Okay, we just have to apply if some elements are smaller than k. Okay, so here elements are smaller, so 1 and 2 is smaller than k, then simply we will apply and push the number that basically minimum of 1, 2 and into may 2 plus maximum of 1, 2. Okay, so what will the result? It will simply give a minimum 1 and 2 is 1, 1 into 2 it will simply give 4, and then updated array will be like, the key thing is that we don't have to decide the place. We can write, it can be anywhere. Okay, 4 can be anywhere. Okay, not in first or last, or okay, that is any specific position. So now also we have two elements that are smaller than k. Okay, we will repeat the thing. Okay, and whenever the elements become greater than or this, basically k equals to 10, k element, or equals to, then simply we will stop the iteration and then simply we will return the number of operations that we perform. In this we have performed till 1. Okay, then if we will perform again. Next minimum element is 3. Okay, and 4. Okay, so minimum, what will the, and we will apply this operation, that is find the minimum and then simply multiply with 2 and then find the maximum and add this with minimum. Okay, then what will the result? Minimum of 3 and 4 is 3 is a 6, and maximum 3 and 4 is 4, so it will be given 10. Okay, will the updated array? Okay, so updated array will look like this. It will remove 3 and 4. Okay, and add 10. Okay, simply add 10. Now if we see that all the elements are is equal or greater than k is at 10, so 10, 10, 11, 10, these two are equal and this is greater. Simply we have to take only 2 operations. Okay, then we will simply, what we'll do is return 2, mainly the operations that we needed to do this. Okay, so you basically got the question, what the question is saying. What can we do? The simple brute force or the simple approach is simply saying that we will take to minimum element of the array and simply perform this operation and push back the new number, and we will remove the previous two, okay, that we have taken as x and y, okay. And then simply we will update the array with the this operation, will perform this operation and update the array with the number that we will get, and then simply perform again till we get the all elements equals to or greater than k, okay. And simply we will return the minimum operation, sorry, not the minimum. So what will be the time complexity then? Then simply minimum value, if we calculate the minimum value, then it will take big of n, okay. So every time it will take big of n for calculating the minimum element, okay. So we can basically reduce this into log n, okay. So we will use priority queue instead of basically anything or another thing, okay. So priority queue, basically what it do is that it simply give a number with priority, okay. So in this thing we will reduce our time complexity of finding minimum element, okay. So that's why we are using priority queue, not array or something, simply iteration through array, okay. So here's the approach, okay. So using priority queue, okay, so simply I will explain what is priority queue in one line. Like, a priority queue is a special type of queue in which every element has a priority, okay. Every element has a priority, okay. What is priority? It will simply depend on condition, okay, what we have given the priority, okay. Simply in this we will use it with heap, okay. Heap, basically what is heap? Heap is a binary tree structure. It has two type, okay, minimum heap and maximum heap, okay. So minimum heap is a binary tree in which every top element is the smallest number, okay, smallest number. So the toppest element will be a smallest number of all the element, and then again small, so it will like 1 and then down to, okay. So the smallest number will be on the top, okay. So you got the thing, okay. Maximum heap, same, just reverse. In this largest number will always be on the top, okay. So this is the approach, okay. So what we will do is simply, this is the example we will take. What we will do is we will first store all the elements in this priority queue in the form of basically minimum heap, okay. Minimum heap, what is minimum heap? Basically it will store the numbers in the smallest to greater, okay. First we will get smallest number first, okay. So how will it be stored? Like, simply here 1 2 3 10 11, okay. Simply then what we'll do is we will simply push, basically what not push, will select the first two elements from here, okay. Simply it will take big of 1 to give us top element, okay. Simply what we'll do is we will take out the top element of this priority queue and store it in the x, okay. Let me write x equals to, what we'll do is pq, priority queue, basically top, I will write top of the priority queue, okay. pq, okay, I got the thing, okay. So and we will simply pop out this element, okay, pop. So what we'll do is the next element will become top, and then simply with that we will store that on the in y, okay, top of the priority queue, okay. We'll store it in y and then simply pop out, okay. So what will happen? We will have two elements minimum in the x and y. Then simply what we'll do is we will simply calculate the operation that was here, this, okay, this minimum 3 4, okay, minimum plus max, okay. This we will simply do this, and then this simply we will push it in the priority queue, okay. So if I write, then simply what we'll do is simply calculate minimum of x comma y and simply multiply it with 2 and plus maximum of x comma y. Okay, and simply push it. Okay, simply then we'll push it in the priority queue, and then simply it will update. Okay, simply 1 and 2 will be removed, and what it will look like simply this. It will be removed and it will simply look like 4. Okay, the answer was 4. Okay, simply then we will iterate it, we will we will take this whole thing in a loop till the smallest element becomes equals to or greater than 2. Okay, we have to do this till while minimum of basically minimum, not minimum, basically top element is smaller than or equals to k. Okay, no, basically smaller than, okay, smaller than k. Okay, till smaller than k. Okay, equals to and greater than r. Fine. Okay, so we have to do this whole operation till top element is smaller than k. Okay, so this is the basically approach. So total time complexity is basically big of NlogN. Okay, NlogN. Okay, and space complexity is big of n, simply because we are using a priority queue. Okay, so this is the basically approach of this question. What we'll do is simply use priority queue with heap, and then simply we can store it in smallest to greatest form, and then simply store the top element, and then simply pop out, and simply push the again new number with operation. Okay, that we have given. Simply then we will, what we'll do is basically take a count variable, and that will basically check how many operations we have done, and simply we will return that number. Okay, so this is the approach. Okay, so I will provide you the code and with code logic in LeetCode. Let's open the LeetCode. Okay, this is basically the code I've opened in LeetCode. So okay, this is the version and this is the code. But we are doing that, we are simply using a priority queue. Okay, its name is minimum heap. Okay, and greater, simply say that it is a minimum heap. It will store simply from minimum to largest. Okay, and simply we have just put the whole nums array in the minimum heap. Okay, nums dot we can do nums on n, and then simply we will take a variable operations, and we will use a loop while minimum heap dot top less than k, that I have showed you in this scally draw. That okay, this was the logic. So we will simply, and then we will take a x variable, store the top, then simply pop out this value, so that next top we can use. Simply we will use the y, then it will again use the top, and then simply we will pop out, and then simply we will push the minimum of this into 2 and maximum of this. Okay, that was the operation. You can see here, this is the operation, and we will simply operations plus that we have taken variable, because we have to basically return the total number of operation to change the array. Okay, and then simply we will return it, and you can check it that this is fine, working fine. Okay, I will provide you the code in through GitHub, and basically in comment I will provide you the link. Okay, so here's the question. So goodbye.